Hello and welcome to the Thoughtworks podcast. My name is Ken Mugrage. I'm one of your regular hosts. With me today as a co-host is Lilly Ryan. Lilly, you want to introduce yourself?
Hi, I'm Lilly Ryan, and I'm another one of the hosts of the Thoughtworks Technology podcast.
We have a couple of guests with us today to talk about kind of a cool new product. Simon Aubury and Ned Letcher. Simon, you want to say hi?
G'day. I'm Simon Aubury. I'm a director of data platforms and I'm based out of Sydney, Australia. It's great to meet you this morning.
Welcome. Ned, how about yourself?
Hey, I'm Ned. I'm a data scientist in Thoughtworks, Australia, Melbourne.
Welcome. Astute listeners may notice that only one of us this time has a North American accent. And so thank the three of you for joining from Australia. So today we're going to be talking about a product called DuckDB, which is kind of a cool new database or newer database that Simon and Ned wrote a book about. A little bit of a departure for our podcast to focus on a specific product, but this is pretty unique and new and exciting and open source and free and all the right things. So with that, I'm going to turn it over to Lilly to run us through some questions and we'll have a good conversation.
Absolutely, yeah. A lot of the questions that most folks have around DuckDB are about, what kind of database is it? There are plenty of database types out there and all different kinds of software that's used for different purposes. What about DuckDB? What makes it special beyond, like a cute name?
I think we kind of need to start off by maybe almost the Wikipedia definition. And then I think if you were to look at the serial box description, DuckDB is free. It's open source. It's extremely fast and it's extremely extensible. And if you're trying to do the mind map of where DuckDB sits within the data ecosystem, it's very much that OLAP, transactional analytics space. And it's really, really helpful for overlapping the needs of data engineers and data scientists. And one of the things that I really appreciate about DuckDB is it's super efficient at getting jobs done. Ned, what would you say were the highlights or the sticker for DuckDB?
Yeah, for sure. This is a bit different to, when we think about databases, we might think about things like MySQL or Postgres. Those are sort of, we've got lots of rows and records and things like applications where you're storing user data for web apps. We're in the analytical world here. So like you said, this is useful for data scientists, analysts, data analysts, and data engineers. We're doing lots of large-scale transformations. I think one of the interesting characteristics is you sort of think about this as columnar operations where we're going sort of vertically. Like we're interested in getting big statistics of big data. So maybe I want to crunch and get the average or the median. And so when you need to do that over large sets of data, we can't do that using these sort of row-based approaches. So that's sort of where we're sitting. But then I guess why is it, why might you be interested in this as a data scientist, data engineer, even software engineer? If you have that sort of a workload, but you just want to sort of spin up this on your local machine or in a small lightweight instance, it's in process. So it runs within the process that, if you import DuckDB in Python, there's no external server you have to set up, no config, and it just makes it sort of that lightweight, easy to access. You don't have to install and run anything. And so I think that accessibility and, it's the sort of thing where you can just, once you learn about it, if you haven't come across it, you can jump in and get started with it super easily. But yeah, we can get further into some of the more interesting and exciting benefits that it has to offer.
You both said, data scientists and data engineers, like these are two different kinds of people. Aren't all data people the same? I mean, I know that they're not. I'm being a little tongue in cheek, but, from your perspective, for our listeners' sake, how do you separate those out?
That is a super good question, Ken. And I think at the end of the day, you're right in that everyone is a data practitioner, but maybe there's sort of an anchor around skill set and a focus to where people's strengths are. So I might identify myself as a data engineer. So I might spend more of my working day thinking about data storage, data transformation, some of the sort of nuts and bolts around presenting data, ownership of data, life cycle of data. And then I work alongside folks who might identify themselves as data scientists or data analysts, and they might be sort of lifting up insights and actually doing exploratory work with the data. So you're spot on that I think we're all data practitioners, but we might spend maybe the majority of our day thinking about different concerns of the data. But one of the things I really like about DuckDB is it's sort of ergonomic to the needs of multiple personas.
How did you both find your way into this particular space? I mean, it's cool when you're talking about a database like this, you're talking a lot about its utility. Not many people would like it enough to write a whole book about it. So what is it about this that's specifically compelling to each of you being data scientists, data engineers, and how did you find your way to this particular place?
I mean, for me, it was suddenly everyone was talking about it. So this was sort of maybe a bit over 2 years ago, a year ago. Back then it was Twitter, not X. It was just sort of all of the buzz, and people were saying, hey, I've been giving this DuckDB for a spin, and it actually allows me to do a whole bunch of sort of common workloads. And I was hearing this from both data scientists and data engineers, and that sort of convinced me that I should take it for a spin. I picked it up, and I actually was doing some scraping of Twitter data using the API before it sort of all got too hard and expensive to use, and trying to see who I followed. And I had sort of, I think something like 70 million records of JSON lines data that needed to be wrangled into a consumable format. And so this is one, I think good sort of use case for DuckDB is just transformation cleaning of sort of interestingly shaped data. And for me, this was JSON, like row by row records of JSON data. And it transformed it in blazing fast speed, and I was like, okay, this is interesting. People are onto something here. And Simon approached me with the idea of pairing on writing a book, and I said, well, that's certainly one way to get on top of this and make sure that I can bring this into my tool chain, and then hopefully, if that is a cool thing, share it with other people. And it turns out it was. So, yeah. How about you, Simon?
I probably stumbled across DuckDB via a different path. I found a lot of my sort of day job working on client sites where I had to deal with a lot of sort of disparate data sources, data in Parquet files on top of Hadoop systems, maybe data persisted on object stores. And there's a lot of very unexciting ways of lifting that data in and processing it. But I found that DuckDB was sort of smoothing away a lot of those paper cuts and just making my life easier. And that was just one of the revelations I had. There was a lot of things I was getting for free by using DuckDB, and by free I mean just reducing some of the day-to-day paper cuts of processing data. Probably a more meaningful example of this is I had a side project where I wanted to do some analysis on my own fitness, and I have a activity tracker that I wear pretty much daily, and I've had essentially accumulated 10 years worth of data. And one day I decided I was going to download the large archive, provided a bit of a history of every sort of time my heart beat, or every time I took a step, or every time I went for a run. And when I pulled down this sort of archive of data, it was something like 70 gigs worth of data. There were close to 85,000 files, and I believe 27 different file formats. And this was just felt like this is going to be a bit of a Herculean task to think, how am I going to process all this data and do some data analysis? What I found with DuckDB was it was actually really straightforward to, interrogate some strange JSON files, parse a whole bunch of fairly esoteric delimited files, and just sort of lift it up very quickly into a notebook so I could do some analysis. And again, it was one of those revelations of this was not a technically difficult task, but maybe a time-consuming task. And I got to that point of being able to do something quite useful with the data much faster than I had anticipated. And it was essentially just smoothing away some of the day-to-day ergonomics of working with data and getting to the important and meaningful stuff. That was why I appreciated the jobs that I didn't need to do with a framework like DuckDB.
While we're talking about the sort of data scientist and data engineer personas, I think it's an interesting observation that actually originally DuckDB was sort of intended with data scientists in mind. It was originally created by the two founders from Computer Science Research Institute in the Netherlands. So it's sitting on the top of a whole bunch of decades of database research. And the observation was, hey, data scientists have jobs to be done that could benefit from a lot of database management technology that we have. So not only things like performance, which DuckDB is great for, but having nice curated tables and data catalogs and things like transactional consistency, so that when you submit a query and something goes wrong, it rolls back to the previous state, which is not necessarily something you get out of data processing tools. And so all that ability to have nice sort of curated data stores to help you, not have piles of, CSV1 and CSV2 sort of renamed and things like that cluttering around. But what was interesting is that it turns out that all of these properties that it was being designed for, it turns out that data engineers went, hang on, this is an amazing lightweight tool for doing data transformation, data management, for analytical data. And so not only is it useful for ergonomic accelerated workflows for data wrangling and analysis, it's also useful as a lightweight building block for lean, fast analytical processing and querying. So we can actually use it for sort of lightweight versions of things like data warehouses and data engines for applications for that software engineers might be interested in. So it's sort of an interesting kind of quirk of how things worked out. All of these different personas, it's an awesome tool for them.
When you've been speaking there about a lot of the different use cases that you've personally come up with, you've spoken a lot about your personal projects and things that you've done for fun, around the sides, that kind of thing. What kinds of use cases have you seen it be used for in a professional environment? You're talking about things that are in process, that are lightweight. It kind of flies under the radar a little bit. Is it capable of doing this kind of work at scale in a kind of enterprise environment?
It's a good question. I think so far Ned and I have been describing what might be considered personal data analytics, or that sort of life cycle of an individual working with a bunch of data, maybe in a notebook or a data science or data analytics capacity. And that's definitely one solid use case for DuckDB. Where I've been super interested is seeing where DuckDB is actually being used in other capacities. So one place where I've used it is in tooling pipelines, where we've needed to do essentially CI/CD on development workflows. So that's sort of integration with build pipelines, integration with sort of modern data tech such as DBT, and DuckDB can sort of sit seamlessly in some of those release processes, which means that the evaluation, the coding, the schema checks are all being handled locally or as part of a build pipeline. And this is great for working across teams where you obviously want to integrate your code quickly and test some of the richness and validity of schemas. And it means that you're not hitting some of the more sort of expensive cloud services. So that's sort of a small example of what I think is a larger movement of maybe sort of cost offset, where you're using very, very capable, free, extensible tooling to mimic some of the behaviors that are also supported by some of the commercial offerings. So I've been using it in build pipelines, but I've also seen a number of clients who are essentially doing what might be considered endpoint simplification, where instead of like taking huge amounts of data that might be acquired by an endpoint, such as a sensor or a network sensor or a telco collection thing, instead of like slurping terabytes or petabytes of data into your cloud data warehouse, which can be quite an expensive thing, being able to essentially do some endpoint simplification of that data and maybe take some of the signals of the data and put that into a warehouse means that you're still achieving the outcome, but you're doing it at a sort of a lower price point, which is, again, another interesting place where DuckDB seems to really straddle having competent data processing, but doing it at a lower price point or localized processing.
So I'm curious, these are problems that are not new, right? And sometimes we see new products or technologies coming out, and we kind of touched on this at the very beginning, like there's lots of databases and so forth. But if somebody wasn't doing this today, or before you all found it, what are the other options? I mean, is this really like leaps and bounds better? Is it incrementally better? What are the alternatives here?
Yeah, great question. I think it's sort of like helpful to think about. Yeah, this is where you want to start thinking about, well, what's your workload type? And hey, if it's analytical, we've got lots of sort of high cardinality, large data sets where you're doing these vertical columnar sort of group by and summarization and joins. Cool. Okay, this is the kind of thing we want to be thinking about. But a lot of times, if you weren't using something like DuckDB, you would be looking at a large, distributed cloud situation. So, whether it's BigQuery, Snowflake, Redshift, or perhaps you're using a bit more of, something like Spark, if it's a bit more of that sort of ETL data crunching kind of jobs to be done. There are also really low latency analytical engines like ClickHouse and Pinot and Druid, which were some of the ones a bit newer to me. I think the observation there is that, hey, a data warehouse is a bit slower. So you wouldn't want to plug your dashboard directly into the curated metrics in a data warehouse. So you'd want to put it into these more low latency analytical engines. I think, so in some ways, yeah, you're kind of right. We had options for these sorts of things before. So it's sort of, but I guess it's kind of, it's about the nuance. And at this sort of scale, it's like, well, the observation is if your data is not, absolutely humongous, like if you're not talking about sort of petabyte scale, maybe we don't need these massive, large, complicated systems that take time to configure, install, run, and tune, and are expensive. So, we're sort of, I think one of the observations is that a lot of these workloads, there's big-ish data, but it's not as big as maybe you need for these big systems. And, when you think about what DuckDB, it sort of, in a way, kind of redefines what big data is. Like big data isn't so big anymore because you can actually get quite large, several terabyte, data crunching operations on your local machine on a laptop, or maybe it's on, a virtual machine in the cloud, and, you can scale that. And so it sort of, it sort of allows you to kick that can down the road before you need to start thinking about those bigger options, is one thing. And then, of course, as we're mentioning, there's the sort of the personal workflows and the ergonomics and things. And that does feel like a bit of a game, perhaps in some ways from the data scientist perspective, maybe that is like a bit more game changing in that we just didn't really have a tool like that. It's sort of a nice database management approach to analytical data. When we compare it to what we would have been using before, it's sort of pandas, data frame processing, or data frames in R, and so polars is the other Python one as well as pandas, and these are really cool tools. Polars is doing awesome things for processing speeds, but it's just a data frame tool. It doesn't give you these data management solutions, so organization and transactional consistency. So there's definitely a sort of a bit of a step change in capabilities that data scientists have there.
Yeah, and it's a super good question, Ken. And just adding on to what Ned was saying, all of these problems were solvable. DuckDB is not solving an insolvable problem. But I think one of the things that I've really appreciated is you're not learning anything particularly new, and this is building on extensible frameworks that already exist. So a lot of data out there can be classified as data that really can fit within memory, really can be processed in situ, and you really can talk about processing things locally. And yes, you can solve a lot of these processing things with existing tools or new tools, or you can write a lot of bespoke pandas or R, and there's some great frameworks out there. But I think one of the things that really sort of sets DuckDB apart is it sort of just embraces a lot of these existing concepts. It exposes everything in a sort of both elegant and ergonomic way. And it's at the end of the day, it just makes jobs to be done much easier. And it just sort of cements everything together in a much more sort of a straightforward approach. So both data scientists can extend tools that they're already familiar with, and data engineers or data analysts can continue working in quite a familiar way, but get a lot of benefits of the extensible frameworks under the covers.
One thing that I think stands out to me as you're talking about this is that this touches a huge number of parts of the life cycle where you're talking about ingesting and cleaning information that you're pulling in from a lot of different sources and connecting to those sources in the first place. And you're talking about transforming it. You're talking about all of the output as well and the different ways that you can work with it. It feels like it's quite like it touches all of these different parts of that process. And it could be quite difficult, I think, to find a way to start using it if it's so broad. When you've approached it and when you've recommended people approach it, how do you recommend people begin? What's a way in for folks who are looking to get started?
I mean, I feel like it's a leading question. There is a book we can recommend you to, which is Getting Started with DuckDB. But seriously, like I think with all these things, finding a data set that interests you, whether you're a data scientist or a data engineer, and maybe you have problems at work that's sort of relevant, find something that, a problem you can sink your teeth into. There's plenty of public open data sets out there. So, in the same way that if you were picking up a tool, like if you're coming from this an analytical perspective, like analytics perspective, you'd go find a data set as a data scientist. I want to get some insights. So I need to clean this, and so you could use DuckDB for that. Like going through all of the cleaning preparation. When it comes time to consuming, maybe you do need to do some converting into pandas or polars, which is very good integration in both the Python and similarly in the R. And then jump in and start doing your visualization. So there would be that. I don't know, Simon, do you have any thoughts around, from a data engineering perspective, sort of like what good sort of inroads might be?
So it's a good question. Maybe I'll take a sort of a slightly spicier answer here. I think DuckDB is pretty much sells itself because it's the things that you're not doing. I don't think anyone should go and learn a technology just because they heard about it or it has a couple of sparks on Twitter or whatever. But I think I fell in. I appreciate DuckDB because it sort of smoothed away a lot of the things that I didn't need to use in my day job. I wasn't writing Python code to pull in files from object store. I wasn't having to interrogate a lot of Parquet files. I wasn't writing reams of transformational logic to transform CSV files. One of the things I really appreciate about DuckDB was essentially that it stopped me from having to learn the nuances of a bunch of different frameworks and tools. So I guess one of the approaches I would take for DuckDB is, do you have a problem that you're attempting to solve with maybe 3 or 4 frameworks that you're familiar with? So my challenge would be, can you solve it with one tool instead of 3? So absolutely agree with everything that Ned was talking about. It's great to get familiar with frameworks through examples or buying wonderful books. But I think my challenge to the listeners is if you're attempting to solve a problem and you think that that path ahead needs 3 or 4 frameworks, maybe just simplify it down and see whether DuckDB would also get you to that solution faster.
If you're going to throw out a spicy take, I feel like I have to add to that. Definitely there are opportunities to sort of rationalize and simplify your tool stack where DuckDB can help you do things that different tools you might have used. That doesn't necessarily mean that we're saying, hey, throw away your other tools. Like don't necessarily replace pandas or even in R. This doesn't replace dplyr over data frames, which is a really nice interface for wrangling data within R. The nice thing is because there's some really great interoperability connectivity with libraries in the analytical data system. So in R, if you it's a very good chance you like dplyr, which is a wonderful interface for sort of describing analytical transformations. It turns out that you can plug that into DuckDB, use DuckDB as the backend, which means that I don't think we've said it explicitly, but as a database, DuckDB uses SQL as its primary language, and some people prefer to use dplyr, and so you can actually just sort of swap that out and then continue to use the same queries under the hood. And there's some interesting stories along the same in Python. So in Python, there's a really great library called Ibis, which is quite like dplyr in that it allows you to do elegant transformations and querying, but with pluggable, composable backends. And more recently, which includes DuckDB. And then more recently, there's actually a Spark interface. So you can write PySpark queries that would be the same as you'd be targeting a Spark backend, which is a distributed sort of cluster-based processing tool, but using DuckDB as the backend, which opens up some interesting opportunities for sort of having simple testing out your Spark queries, in continuous integration environments and things like that.
So it'll work within whatever you've got going on, as in you don't have to swap out everything, you don't have to throw it all away, but it could integrate at different points.
Yeah, that's right. And there's opportunities to shift some of the things into DuckDB. So I'd say use the right tool for the what its capabilities are. So if you're already using something like pandas, maybe some of the processing that you're relying on pandas, bring that into DuckDB, because DuckDB with its sort of more lazy operations where the transformations doesn't have to be materialized at each step of the pipeline. It actually creates these nice lazy representations that can be optimized for the end-to-end for the query. So bring your transformation operation into DuckDB, but then turns out a lot of the next thing you might want to do is visualization using a data frame from pandas. And so that's still, export to pandas is the last step. So not necessarily replacing things, but, working out what the right tool for the right job is. Or if, as Simon said, if it turns out actually maybe, you don't need one of those tools, then you have rationalized your tech stack and made things a bit simpler.
What are you folks excited about coming down the pipeline next for this entire ecosystem? It feels like it's not just DuckDB, it's expanding fairly rapidly the more people realize the value to be had in managing data effectively, wherever you are with whatever you're doing. And I think that the both of you and the work you're doing are seeing a lot of very interesting trends that are coming up. What are you most excited about here, and where do you think it's going?
I think there's two things that get me very excited about both DuckDB and the ecosystem more generally. The first one is probably what's possible when you don't actually unencumbered by price. An awful lot of really great processing is now possible, locally exploiting some great technology that you have possibly within arm's reach. We're talking about the power of your laptop, the power of your browser. DuckDB runs pretty much everywhere. It can run in memory. It can run through WASM in a browser, and it really increases the surface area of places where you can do processing, and essentially processing for free using existing hardware.
If I'm honest, that scares me a little. So we're talking about a very extensible system that can connect to lots of things, that can run anywhere, and so forth. How do you protect that? How do you secure that? How do you make sure that no one's? I'll put on my Lilly hat here, who runs InfoSec for us in Australia, New Zealand. Scary. Make me safe, please.
Yeah, well, I think nothing's ever perfect, but I think possibly one of the most battle-tested bits of code working in one of the most hostile environments would be a web browser. And the fact that we're talking about WebAssembly as possibly an execution environment for untrusted code with a lot of sort of sandboxing and a lot of compartmentalization. If you wanted to do some rich processing in a hostile environment, I think one of the places that you might want to consider as one of the most battle-tested bits of code would be some of the code paths that are already available and battle-tested within your web browser. So the idea that the memory space is separate, the virtual file system is separate. I do like to think that it's a better place to be rather than building code from scratch, that you're building from some of the frameworks that already exist.
I think the other dimension to add to that is maybe the other way to respond to the question you're asking, Ken, is well, hang on, if anyone can just install it, anyone can do whatever they want. This is almost like the shadow engineering. It's sort of like, well, I've got problems to solve and I can use this tool. I'm going to go and install it. I mean, it's true, but that is also true for things like pandas, which is, it's hard to answer the question how many people use DuckDB for the same reason with pandas, because anyone can pip install and start using it. And so I think, what I'd say is, well, this is a tool that is actually going to help people bring kind of cleaner and more organized patterns. So you're actually giving them access to a better, depending on the use case, oftentimes a more appropriate tool to help you do things sort of closer to, nicer sort of best practice, cleaner ways. So I think, all of the problems around that governance and what you can and can't do, they still exist. But a lot of that does lie in, well, can you access the data? And, that those governance and data access and lineage things, like that's all still there. And we must, think about how to build that into how we do things. But it's still a relevant concern, but I don't know that it necessarily changes the surface area of them.
You folks have just written this book about getting started with DuckDB. I think it was the first book that was written about DuckDB ever, and there are a few more now, which is really great. We've also talked a lot about the way that this can touch different parts of the ecosystem, different parts of the environment, and I think, for me, listening to it can be a fairly overwhelming thing to contemplate in the whole. If you were going to point people to a place where they could look to get started, not just with DuckDB, but with also thinking about how to work with their data in a better way, or how to maybe even connect to DuckDB in different parts of their stack, where would you go? What would you recommend that people look at?
There's a few really good online resources. So DuckDB.org, the homepage of the project, is a great place to go. The documentation is really awesome. In addition to that, there's also a Discord community. That's a great place to go and chat to community members and contributors to the project. There are, jumping online to, whether it's on, X, previously Twitter, LinkedIn, and Mastodon. There are people talking about DuckDB. So lots of community things going on. DuckDB project has a regular DuckCon conference, and then maybe I guess the other part to your question. I don't know, Simon, did you have any thoughts around sort of getting started with like kind of analytical endeavors more generally?
I mean, everything that you said, I did actually just wanted to emphasize the wonderful community that has both made core DuckDB very, very solid. I know I had a problem a while ago where I was trying to process something ridiculous like a JSON file with over 700 million rows, and I hit a small processing error. It was a completely infeasible problem to solve, and one of the developers within 24 hours submitted a PR and essentially fixed the processing problem I was having. But more generally, I love the community that's spawned around DuckDB. There's a wonderful and vibrant ecosystem for extensions, everything from geospatial, vector processing. There's all sorts of communities that have sort of cross-compiled some very specific frameworks, and they've all been expressed and imported as extensions into DuckDB. And the way to get sort of both inspired and familiar with that, as Ned said, is either the online documentation, which is fantastic and open source, and the Discord community that have also been very flourishing and growing quickly. And I found that a really both inspiring and supportive environment to ask questions and get inspired by potential.
There's also the awesome DuckDB GitHub repo, which has an amazing collection of resources. And if you're interested in looking and getting started in analytical data more generally, I think that there's plenty of resources out there, sort of blog posts and books, and it's sort of, getting started with data analysis and diving in. And I think it's a good question, Lilly, because it can be hard to know how to get started because there's so many different ways to do this. Some books will be using a tool like Pandas if you're a data scientist. Some will be using SQL. A lot of these are the same concepts. So I think sort of look for, if it's something involving, if you're going to be using SQL with DuckDB, then other resources that involve SQL are relevant. Of course, it's interesting that DuckDB has its own nice ergonomic flavor of SQL, which we didn't mention, but brings a whole lot of niceties to it. So I think that, there is a really rich array of resources out there to mine from. And once you sort of get sort of where does DuckDB sit in the landscape, I think you can sort of work out, okay, this is the sort of the relevant jumping into analytical resources to dive into.
Well, speaking of a rich array of things to dive into, we didn't get into the rich array of duck-related puns that this affords us, which I'm going to leave as an exercise for the listener. Thank you both for joining us today to come and talk a bit more about this ecosystem, about the tool, about the ways that it can be used in so many different places. Hopefully we've inspired a few more people to play around with some of these things or to read up more.
Thank you for your time, Lilly, and good talking to you as well, Ken.
Yes, thank you very much, everyone.
Thanks a bunch.